So your goal today, test whether a function is differential at a value of x and sketch the graph of the derivative. So it's a simple test to see if a function is differential. Okay, so let's say there's a point A on the function, or x equals A. The function must be smooth and continuous at that point. Okay, so first of all, what is a function? I think of it like a machine. So you're putting something into the machine and you're getting something out. Okay? So have you heard of the vertical line test before?
Does it pass?
Maybe you have, maybe you haven't. It means when we put a number in, we're only getting one number out. Okay? So vertical line test means when you go down any part of the function, there's only one y value. Does that make sense? Yep, so I'll draw an example of this. So a classic example is just your good old quadratic. You know, when you do the vertical line test, is there always just one y value? What about now? If we do the vertical line test at a point, is there more than one y? Yes, so it's not a function. When you put question, can you have more than two x values for one y value in a function? Yes. Okay, but you can't have two y values for one x value. Okay? Is it clear? So it's all about the vertical line test. If you do the vertical line test, any point on the function, and you find that there's more than one y value, so this function, it's a function because there's only one y. This one here, do the vertical line test, it's not a function. Okay? So we're thinking about, is a function differential at a point? So first of all, is it actually a function, vertical line test? Is it continuous? Can you draw it so you never lift your finger off the page? If you can, it's continuous. Okay? A much more formal definition is at that website. Is it smooth? Okay, so this is the bit that may confuse you. So smooth. So if we draw, you guys are familiar with piecewise functions, hopefully. Yep. So if we draw a Cartesian plane, so familiar with the piecewise function, hopefully. It's like a function that at a point changes. And this point is A for all intents and purposes for this. So we have, you know, I don't know, the function equals, I don't know, negative 2x, and then the function becomes, I don't know, 3x or something like that. Okay, so you're used to like seeing it with the squiggly brackets like this. Does this look familiar? Hopefully. And at some point, it's equal to I don't know. Sorry, x is equal at some point, and x is less than at some point. Okay? Is there any questions? Probably more like that. So the point is, in this three-step determining if it's a differential or not, you've got to think about, at that point A on the graph, does the gradient have the line between that point and more than that, so plus A? And is that gradient of that half of the graph equal to the gradient of the other half of the graph? Does that kind of make sense? That's what that third point says. does the gradient of the line on one side of, like, so is this gradient equal to this gradient, is what it's saying. So what's the derivative of that? -2, and what's the derivative of that? Okay, so you're just finding the derivative of the separate functions within the piecewise function. So that's some questions ask you to do that in the textbook. Okay, so that's the three kind of check. I mean, here's another note for piecewise functions. If you're looking at the graph of piecewise function, like the one I had up on the screen before, it's quite easy to see the gradients are not the same, right? It's quite clear they're not the same gradient. The gradient is the differential, by the way, if you forgot. Okay? However, it's not always that clear cut. So, you know, I gave you an example of a piecewise function that was clearly gradient, gradient. You know, they were both linear, they both had, you know, obviously the different gradients, but it's not always that clear cut. So if you're going to look at a piecewise function, you must look at that intersection point, so that A point on the graph. Okay, you must compare at that A point. Does that make sense? So if you get a piecewise function example, find the derivative for both of the functions in the piecewise at that A value. The question will probably give you that. It will give you that A value. So it could be x equals 1, it could be x equals -1, whatever it is.